There is also another thing called as a blocking and non-blocking statements in Verilog. Let us see what are these. Are very, very dangerous mistakes in Verilog. So we should understand this very clearly. So what is a blocking statement? This blocking and non-blocking is coming only into the picture when we are using always block. Okay. So inside the always block, if I'm using equal to make assignments, I call that as blocking statements. So how the blocking statement executes? It executes in order it is written. In the way it is written, it will be executed. So the first statement is evaluated first and the second statement is evaluated next. Here, the behavior is like a C program. Whereas in case of a non-blocking, it executes parallelly. The non-blocking assignments are by less than equal to. It's not a plain equal to, it will be a less than equal to. So inside here, whenever I'm using a non-blocking, what will happen is the moment I enter the always block, all the RHS will be evaluated. Say for example, I have multiple assignments inside my always. So this is my always. So I have multiple assignments, A equal to B and C, and then E equal to some A and F, something like this. So all these assignments will be evaluated first. All these assignments will be evaluated first, and then these will be assigned. So the order doesn't matter because it's like a parallel evaluation. The order doesn't matter. Now because of this also we will see mismatches. What is the So what are the caveats with blocking statement? Let us take a simple code here. These are very, very beautiful mistakes people do. We should be very careful. So here I'm trying to create a shift register. Okay, I'm basically, my aim is to create 2 flops. This is my aim. Let me mark it clearly. Upon reset, they are 0. This is a asynchronous reset. And I have an input called D and the output called Q. This is my aim, to create this shift register. So the D should go to Q0 and Q0 should come on Q. This is my aim. Now let us see what happens. I am using a blocking statement. Clearly, if you see inside the always block, I am using equal to make assignments. Now here there is no problem. Both are getting assigned to one tick B0. There is no problem. The asynchronous reset connection is happening here. So we have a reset connection. Now look at this. I am assigning Q0 to Q first and then Q0 to D. D to Q0, correct? So the assignment first this statement executes, then this statement executes. So Q is assigned to Q0 is assigned to Q. So Q0 is assigned to Q and then D gets assigned to Q0. D gets assigned to Q0. And all these things are happening within the passage of clock. So we get flop like this. Okay. Now this looks correct, right? Now let's see what is the other way of doing it. Now let's say for example I wrote it like this. I changed the order. I wrote Q0 equal to D first and Q equal to Q0 first. Then what will happen? Let's see. This portion of the code is same. There is no change here and here. So there is no problem. Now here I'm making Q0 equal to D first. That means D already. So I told you, right, whenever we are using equal to, the order of execution will be in the same order in which we have written. So D is assigned to Q0 and then Q0 is assigned to Q. So by the time the statement called Q0 assigned to Q is evaluated, Q0 already has the value of D because this statement executed first. This is executing second. Look at this statement here. If I compare these two, here Q is having the value of Q0. Q is having the value of Q0. Then see, this assignment already happened. This is the first statement. This assignment already happened. Then I am assigning Q0 to D. Then I am assigning Q0 to D. Because the and statement 1 has already happened, I cannot go and undo it. So Q will have the value of Q0 and Q0 will have the value of D. So there are two storages happening. Whereas here that is not the case. Q0 is assigned the value of D and Q is getting the value of Q0. And Q0 has the value of D. By the time Q is assigned to Q0, Q0 is already having the value of D. That means there is only one flop here. This is D, this is Q. This is a serious problem.